Say something from, just follow on from last time, that's all right, about information. That was key to everything. So, I don't know if you guys, have you heard of Ray Comfort? You guys seen Ray Comfort? To his Evolution versus God movie and different things. He's very talented, very good at telling people about the gospel. But he went and visited this guy named Lawrence Krauss, who's a physics department chair where I went to school at Case Western Reserve University. He wasn't there when I was there, but he later years was there. And he's a Jewish atheist, and he wanted to ask him 3 questions, and he asked him these 3 questions about creation. If a book came down from heaven, book a magazine with all the pictures and writing in it, and said, would you say this could just happen by chance, just falling down from the sky and creating all the words and the pictures, beautiful pictures in it? And he said no, but it possibly could, but I don't believe it did. But anyway, he did a good job asking him the questions. But then Lawrence Krauss said, well, order can come from just natural processes, and he gave the example of snowflakes. And he said there's an infinite number of snowflakes, and they're all intricately, he didn't say design, but they're all intricate forms and shapes, and there's an infinite number of them, and they just come by natural processes. So Ray Comfort didn't address that, but I'm going to address that now. How does that happen?
Is it key to know the other 2 questions he asked?
No, not key. So how does that happen? It's still information because a water molecule's got. What does a water molecule have?
Start again, I didn't hear you.
What atoms are in a water molecule?
Hydrogen and oxygen.
H2O, right? So there's oxygen and there's 2 hydrogens. Wow.
Uh-oh, different color.
We're gonna have to use
Crazy. Oxygen and 2 hydrogens. Remember how we said that matter actually is energy plus information plus mathematical formula plus structure? So the oxygen has a specific order and structure and information, content, and the hydrogen does. So that allows them to combine, and they combine based on all those structures and formulas in exact way and exact shape. You can't have H3O, it's not stable. Because of the information that is on them, it restricts and determines what kind of configurations water will form. And there's like 104, this angle is 104.49 degrees. So, this is a triangle. Now it can crystallize and form structures when it freezes, combining to form a crystal with other water molecules. But everything that comes out of this, every single snowflake, is going to be governed by these triangular angles and this information that's in the original molecule. So you can get an infinite number of snowflakes, but every single snowflake will have 6 sides. There's not going to be a snowflake you'll ever find that's going to have 5 sides. There's not going to be one that's not going to have these exact angles. There's going to be an infinite number of designs, but they're all going to follow this pattern because this is the information that is already in the molecule. You're never going to get a nice swan sculpture that you see at some Christmas party. That will never happen by chance because the information's not there. But the information is there to form an infinite number of 6-sided, particular 104-degree angle snowflakes. So that's what, so then it could go back and I would say, so, Lawrence, where did the information come from for the atoms in the first place? Anyway, I just wanted to review that a little bit. So here's, we're going to do the flood today, starting from the very beginning. So, at the end of this, hopefully you guys are going to be able to say what is, like, you know how the super sign for the end times is Israel's back in the land, right? So there's a super sign that the flood happened. So you're going to be able to say that. You're going to be able to say other things probably, but we're going to have a super sign. Anybody have an idea what that is? Anybody?
Grand Canyon?
Well, you can see it in the Grand Canyon. That's good.
The
Debbie knows.
great unconformity.
Ding, ding. That's right. The great unconformity. I'm going to explain all this, okay?
That's not fair, she's your wife.
I know, she's cheating.
It's only because I've heard it like 12 times. Maybe 14.
Well, also, I was gonna say, on the tops of very high mountains, they found fossils that are for creatures that live in the ocean.
That's correct.
So there's no way that those creatures would be able to swim up to a mountain unless there was water that was above the mountain.
No, that's true.
So,
And what did you all just try to explain it is say it was way down underwater and then it was uplifted and now it's way high and the fossils are exposed of marine creatures on Mount Everest and other places. That's how they would explain it over a long period of time. But what we're going to do is, so the Grand Canyon, we're going to look at evidence for the flood in the Grand Canyon. Why in the Grand Canyon? Because the Grand Canyon is a place where the water has cut through a mile of rock and it's pretty arid, so it's not highly vegetated. So you can see the actual rock. It's like a cross section. You can look right at it. And so it's very interesting. You can see sort of this long history of the earth in there. So here's a picture at the bottom of the Grand Canyon in 1986 when I hiked down here. And these are some of the people that were on the hike. Joe just went on the hike explaining some things about the Grand Canyon. And you can see here, see the water in the Colorado River. What color is it?
Brown.
Brown. Why is it brown? Sediment, right. It's got tons of sediment going down the Colorado River. Now, if you take various samples and a statistical sampling of the river, you will be able to determine how much sediment is on average in the river. And you know the flow rate of the water going down the river. There's lots of dams on the river, so we know that extremely well, very well characterized. By the way, the river doesn't take as much sediment down because of the stopping of the dams as it had in the past when it didn't have any dams. But given that flow rates of the river and the amount of sediment in the river, it's a pretty easy calculation to say how much rock is going down that river every single year. If you take those calculations, the density of the rock and the volume, the amount of sediment going down the river today, how long do you think it would take to carve that entire Grand Canyon out?
well, what kind of rock is it?
Well, there's an average density of the rock, different kinds of rocks from the sides of the canyon, but you get an average density about 71,000 years, only about 71,000 years. So the canyon, there's no way it could be millions of years old. It would have been completely gone and eroded away, just at current erosion rates. Now, when the river has been at flood stage, which there's evidence in the canyon it's been at much higher levels in the past, when it was at flood stage, it would take 11,000 years to erode away the entire canyon from a perfectly flat surface. So there's the canyon. You can see it. This is a picture I took from an airplane flying over it. You can see the inner canyon here with the side canyons, and then the plateau, the Tonto Plateau, and then going up to the ridge on the outside. You see the ridges on the outside, pretty flat. Comes in the north rim to the south rim is a little lower. It's kind of a flat curved surface, fairly flat. And the canyon is eroded away. It gets wider and wider as it gets closer to further downstream. Now, you can see it's 500 miles long, it's about 5 miles wide, and it's about 1 mile deep at the deepest point. So you can calculate the cubic the cubic volume of rock being eroded away and do these calculations fairly easily, how long it will take to erode it away. How many of you have been to the Grand Canyon? Nobody's been there? Oh, it's amazing. If you ever get to go, go. So here you see, we're going to talk about the Noah flood and the Grand Canyon. Here you can see something interesting about these rocks. Now this is down into the canyon looking at the side of the canyon. Do you notice something about this area right here? Do you see these rocks below are at an angle? Now, you see they're flat layers that are laid one on top of each other. Very, very flat layers, but they're bent. All the layers together have been bent, and they're at an angle, and then they've been basically shaved off, and all the layers above are flat above it. See those layers that are flat above it. So the layers above conform one to the other, flat on another, but they do not conform to the layers below, which are shaved off at an angle, because they're at a different angle. So that's called a unconformity. They do not conform. Now, there are different unconformities that you see around the world, but there's one unconformity that is called the great unconformity. And we're going to talk about that. You can see it, you can just see it very clearly in the canyon, but it exists all over the world.
Is it recognized all over the world?
Recognized all over the world. It has the term, the great unconformity. It's great because it's all over the world. Every single continent has it. Now, so here's a schematic. I just pulled it off the internet. The basement rocks, which are not, they don't know where those rocks came from. They say they might be from volcanic or igneous or cooling lava or something. But it's called schist. It's not sedimentary. And then there's the rocks that you saw that were at an angle. Those are all sedimentary. Those are all laid down underwater. It's called the Grand Canyon supergroup rocks. And then you have the great unconformity here. There it is. And above it you have all these other layers that are basically flat laid upon it, on top of it. Almost a mile of rock, and all flat.